So we are going to be learning to understand the notation of transformation. So we have dealt with real numbers before, and real numbers are focusing on a number line. But is when we have the r with the power of 2, that is referring to ordered pairs, and that is referring to a 2D plane. So all possible coordinate points. Um, a quick table will show you the difference. So we've got r, which is just focusing on the number line. We've got r to the power of 2, which is the Cartesian plane. And then we've got r to the power of 3, which is the 3D plane. So just quickly, what does it mean? This is referring to the transformation that is taking place from the x and y to the new point on the plane. So we're going to answer a couple of questions and to really break this down on what it actually means. So this first question says the transformation is described by r squared to r squared for t is x, y is equal to x minus 1 and 4y plus 5. Find the equation of the image of the graph. So the first thing we need to do is find the image. So we're going to identify x in terms of the image. So that means I'm just saying this part here, x minus 1, is equal to the image. Now I need to get it in terms of x. So I'm going to get x to one side. So I'll add 1, and that gets me x is equal to the image of x plus 1. Likewise, I'm going to do the same for y. So I'm just going to rewrite 4y plus 5 is equal to the image of y. Okay, so that gives me the image of y is equal to 4y plus 5. The next step is to get y by itself, to get y as the subject. So I'll take 5 away and then I'll divide by 4. Now we've got these two, we are just going to substitute both of these into our function, and our function of f of x is equal to 5x. So all I'm going to do is grab those 2 points and place it into our equation. I just need to simplify this now. So that means I'm going to times by 5, and then I'm going to plus 5. With this question, I am unable to simplify it any further, so I've just got y is equal to 4 times 5 to the power of x plus 1 plus 5. Here we've got, we're going back to composite functions. And so we need to be thinking about with composite functions, if we've got something inside, it's going to be substituted into the next equation. So we need to be, if we were given the functions, we would be looking at our range of our first function must be able to fit inside the domain of our second function. But in this case here, all we're thinking about is an understanding of our composite functions. So I'm just going to grab T1 and I'm going to be then substituting that into my T2. So T2 is x minus 5, and then I've got comma, negative 2y. So if I go and look at my T1, I've got 3x there. So instead of having x here, I'll substitute 3x in. Instead of having the y here, I'm going to substitute y plus 4. And I put it in brackets. I'm just going to simplify this. So on my left-hand side here, I can just take those brackets away. And on my right-hand side, I've just got negative 2 times y is negative 2y, and negative 2 times 4 is negative 8. The last question I'm going to go over is understanding of inverse. So one of the things we've done with inverse before is we're always talking about the x and y are going to be flipped. But we're wanting the inverse of the transformation. So the first thing we need to do is recognize what is the transformation that has occurred. So with the image, so we know the image of x is 4x minus 1, and we know the image of y is negative 3y plus 2. Sorry about that, Bill. Okay, so oops. So the next part we need to be thinking about is the inverse. Now, because we're looking at the inverse of transformations, we are just going to flip the x and the image. So that's all I've done. And then again, I'm just going to get this x image by itself. So that means I will add 1 and then divide by 4. I'm going to do the same for my y. So this image of y and the y will switch. And then again, I will get my image by itself. So I will take away 2 and then divide by negative 3. Now I know my inverse of the transformation. I can put it in the transformation notation. So the inverse of the transformation xy is equal to x plus 1 over 4, y minus 2 over negative 3. I could have simplified this further just by not having a negative on my denominator, but I've just left it in this form.